Hello, my name is Darwin Shang, and today I'll be showing you how to install and run Footprints on your computer. Footprints is a program that counts the number of bases in a BAM that have a minimum coverage of anything you provide. And this is important because it more accurately calculates mutation burden than simply providing the number of megabases um, in a bed file. Because oftentimes when sequencing actually occurs, sometimes certain regions are not sequenced deeply enough to detect mutations. So Footprints requires two softwares, SAMtools version 0.1.19 and Bed Tools. Um, the author, Ellie Fewings, makes it very easy to install SAMtools um, and you can do this just by simply copy and pasting each line to the right of the dollar sign. Just make sure you don't copy the dollar sign itself. Um, Pasting it onto a terminal and pressing enter for each line. Now I've already done this, but it should be quite easy. What you should do at the end though is just make sure that you are on the correct SAMtools version when typing in SAMtools. So just test typing out SAMtools. We'll see here that we have actually version 1.9. So in order to make sure that we have the correct version, we need to re-export. Um, and the important thing is that we need to change the paths to SAMtools to squiggly and a forward slash. At least wherever you install your SAMtools folder. So now we'll type in SAMtools again, and then you'll see that we have the correct version here. Now for bed tools, they have similar instructions, but I would actually take this opportunity to install Homebrew. Homebrew is a package manager that essentially installs packages for you. It goes through a lot of the more difficult steps with certain packages and your computer configuration. Um, so overall, I would try and go through the step-by-step process to install Homebrew. And then after that, copying these two commands and then pasting it onto terminal as well. So at this point, you'll have both of them installed, and then we need to actually install Footprints. So to do that, we need to go back up to the top, press the code button, press the clipboard, and what this does is it allows us to basically clone this um, folder onto our computer. So if you just type in git clone and then paste the link, you then get the software itself. We then need to cd into the folder, type in auto reconf -i, just wait a bit. What this does is it configurates the program, again, for your computer more specifically. So after that, we can then run these two commands, which is /configure, and then make. Now if we type in /footprints, we should get the script. Okay. This is just the standard output if you type in footprints -h, anything like that. So now we can try and run it. So for example, I'm going to run this on patient 6. BCC 15 exome. So let's just quickly look at the inputs that we need. We need a BAM file, we need a intervals bed file, and minimum coverage, and an output file if you want. So really quickly, let's type in the command itself. So we do footprints -b and then we can just drag the BAM over as our first input, minus I. And for the inputs, we then need to insert the bed file, and you can do this by going under sequencing data, sequencing bed, and for exome, you're going to want to use the CCAP Easy Exome version 3, and for UCSF 500, you'll be using the NimbleGen v4. You want to use the targets bed. So here it would be the interest.bed, but for exome, we want to use the targets.bed. Normally, we want to put a minimum coverage. So as you can see, it says minimum number of reads a base needs to be covered by to count as part of a callable footprint. So the default is 5. That's what we use for our normal mutation burden project. And then output file, we can just output it to just somewhere, patient 6, BCC 15, E for exome.text. And this will just take a while to run. So I'll just skip to when it's finished. Okay, the program is now finished. The number of base pairs with more than 5 coverage is 59 million, approximately 60 million to round up. So what you need to do now is go into the sample summary, locate your cell. So in this case, it's patient 6 BCC 15. Go to exome, footprints, copy and paste this number into there, and that's your value. Hopefully this has been helpful, and thanks for watching.